Hi, my name's Alison Thomas. I'm an environmental health practitioner and housing consultant with RHE Global, and I'm here today to talk about understanding and managing damp and mould in domestic properties. So just a little bit about our company then. We're a company that specialises in environmental health and community safety, consultancy, training and software solutions. So we've supported the Safe Suffolk Renters project with some consultancy services. We deliver a lot of services to local authorities. We also support government. We delivered the HHSRS review for the Department of Levelling Up and the Welsh Housing Quality Standards for the Welsh Government. And we deliver software solutions in terms of our REMS database of procedures for local authorities for their enforcement activities. We produce the Noise app, which is for reporting noise complaints, and the Housing app for conducting housing inspections and HHSRS assessments, as well as HHSRS training. So what is damp and mould growth? Well, you should see a definition there on screen. That's the World Health Organization definition. So we're looking at visible, measurable or perceived outcomes of excess moisture. So that will often be visible in terms of damp staining, discoloration and accompanied by mould growth. So generally there are three main causes of dampness to a domestic property: condensation, rising damp, penetrating damp, but there could also be what we tend to call traumatic damp, pipe leakages and spillages. The focus of this presentation, because we're talking about moisture management, is going to be mainly about condensation. So why is it important to address damp and mould growth then? Well, there are a lot of health impacts to being exposed to damp and mould growth. So there's a few different kind of evidence-based definitions on the screen there. We're talking about physical health impacts. So we're talking about respiratory impact, respiratory illnesses, asthma in particular, allergic reactions as well. And there's a lot of evidence around that in terms of those links to those who are living in houses with mould growth, exposed to mould growth and those kind of respiratory type illnesses. But also we need to think about the mental health impact of living with those kind of conditions. So, you know, really unpleasant living conditions, how kind of depressing that is. It can make people feel quite anxious. You know, they might feel anxious about the physical health impact. They might feel anxious about health impact on their dependents. It can lead to social isolation. People don't want visitors in their home, and it can lead to the destruction of properties and belongings. Condensation can affect our belongings, our furniture, our fixtures and fittings, as well as the actual property itself. We know that housing conditions, and particularly damp and mould growth, has been in the news quite a lot recently. And one of the main cases has been about the death of Awab Ishaq. And I want to focus on a few key points within that case, okay? We know that Awab died of environmental mould exposure, but there were a few points drawn out by the coroner's report in terms of how professionals dealt with that case. The landlord, the housing association that was the landlord of that property, didn't address the underlying cause of the mould, and in actual fact they blamed the family for causing the mould growth, despite the fact that there wasn't adequate ventilation in that property. So when we think about the conditions in that property, actually there was a fan in the bathroom that didn't work properly. There was no window in that bathroom. In the kitchen there was no extractor fan, and the window in the kitchen actually opened onto the communal walkway rather than into, you know, directly into outdoor space. One of the things that the coroner said in terms of the ruling of Awab's death was that professionals placed too much emphasis on the cause of mould being family lifestyle, and that homes need to be habitable for modern living, and that that family in particular didn't live an excessive lifestyle. It was just normal style living. And that's one of the things we're going to take forward as we think about how moisture behaves in dwellings. So whether you're investigating housing complaints, you're an inspector, you're a housing provider, one of the things we need to understand is how moisture behaves in dwellings and the root causes of any damp and mould growth. So when we think about moisture, it's not just visible dampness, it's not just water itself, it also includes ice, it also includes water vapour. So air naturally contains moisture in the form of water vapour, that's humidity. And in order to keep buildings healthy, we, as well as controlling how moisture enters the building, we need to understand and control how humid air leaves. And if we don't do that, it will lead to condensation. So think as well about different types of buildings. So on the screen here, you can see on the left a really kind of traditional dwelling, and on the right a more modern building. And these buildings interact differently with moisture within them. So a traditional building, we're talking about anything really pre-1919. We're talking about solid wall properties built with traditional techniques with natural materials. In those traditional type buildings, they're built to be what we call vapour permeable. So moisture is able to leave through the building structure. And they're designed to have high levels of natural background ventilation. So as well as air leaving through air bricks and chimneys, those vapour permeable materials, moisture can move through the mortar in the walls. So rather than cement mortar, they're built with earth and lime mortar, and that's what we call hygroscopic, which means it can absorb moisture. And it's really important that when we carry out repairs and retrofit, it's in materials that maintain that vapour permeability so that we keep that moisture interaction in the dwelling the same as it's always been. When we think about our old buildings as well, they were designed for a different style of living. So a lot of water use was actually outside, people bathed outside, people washed their clothes outside, and there was a fire burning constantly, so there was constant source of heat and ventilation. But our modern lifestyles, we've changed the pattern of living in our internal space, and we tend to repeatedly heat and cool it because we're out at work, we're out at school. When we think about vapour permeability, an example of vapour permeable design and materials is in a brick-built Victorian house. It's designed to be built with lime mortar rather than cement mortar, and the lime mortar is hygroscopic. So in the photo, you can see a photo there of some bricks, and the faces are wearing away, and the mortar is kind of standing proud within the bricks. And that's because at some point the building has been repointed using cement mortar instead of lime mortar. So as I said, moisture can travel through lime mortar joints, but cement mortar isn't vapour permeable. So in this picture, the moisture hasn't been able to move through the cement mortar, so it's gone through the bricks, so it's damaged the brickwork. On top of that, cement mortar doesn't really bond well to lime mortar, so that can also trap moisture within the bricks, leading to frost damage. So in this particular case, what we saw was that actually all the repointing that had been done in cement needed to be scraped out, and that needed to be repointed with lime mortar to maintain that moisture route. And we can see those kind of issues internally as well. If a building's designed to be vapour permeable, but it's been replastered and repainted with non-vapour permeable materials, that can actually impact our moisture management as well. And sometimes you might need to bring in a specialist to help you diagnose those particular issues. So thinking about condensation then. So condensation is the process where water is deposited from air containing water vapour when its temperature drops to or below dew point. So dew point is that particular temperature at which water droplets start to condense on surfaces. Dew point will vary between environments depending on the air pressure and the humidity. Basically, when the internal air is warm, it holds more moisture, and as it cools, it can hold less moisture. So the water in the air will start to condense on the coldest surfaces. If that surface isn't hygroscopic, so it doesn't absorb moisture, it will stay on the surface and it'll allow mould to grow. If it is hygroscopic, then sometimes the moisture will absorb into the material and then it can evaporate out again internally or transport through to the exterior, dependent on the relative humidity. So it allows a kind of passive regulation. But when it's not hygroscopic, it will just sit on the surface because that warm air will cool and give up the moisture within it. So there are three main factors that contribute to condensation. The humidity of the indoor air. So that's, like I said, when the indoor air in a room can't hold any more moisture. It's got a high humidity, it's got a high level of water vapour within it. So that's when our condensation occurs. Low temperatures, so when the humid air comes into contact with cold surfaces, then the air chills and releases the water. And poor ventilation, so the humidity of the indoor air can be reduced by ventilation. So if our air exchange isn't adequate, then the humidity will accumulate and increase our condensation. So bearing in mind those three main factors, the type of things that are going to impact those are the type of dwelling, the construction of the dwelling, the degree of insulation, the amount of ventilation, the type of heating and the level of heating, the weather conditions, the location of the property in terms of, particularly coastal locations, for example, and the number of occupants in the property. And some additional issues here that kind of contribute to that as well. So as I talked about earlier, changes in building characteristics, the fact that we don't tend to use those open fires anymore. We've got an increased use of double glazing, so we've started sealing up our houses, making them more airtight, and poor insulation and heating, leading to those lower temperatures. And we've also got changes in living arrangements, so our dwellings being left unoccupied during the day, different types of heating systems, more frequency of clothes washing, and we have higher density of occupations. Cost of living crisis, lots of people with their, children staying at home longer to reduce costs of housing. So on this slide here, on the left, you can see there I've tried to demonstrate what the envelope of a building looks like. So our building envelope is the black line on the outside. It's the structure of the building. It's the physical separation between the conditioned internal space and the unconditioned external space. So it's continuous. It's our floors, our walls, and our roof line. Within that, the red line is showing the thermal envelope. So that's what envelops the insulated space within a house. It separates the indoor and outdoor temperatures and stops heat from escaping. And the reason you see the line at different levels there at the top is because the black line is depicting the roof. In this particular case, the red line is across the ceiling height because that's our loft insulation. So that's showing the difference between the thermal space and the building envelope. So you might have heard the term thermal bridges. It can also be called a cold bridge or a cold spot. So essentially that's an area of the building's thermal envelope which has a lower thermal performance than the surrounding areas, and I've marked those with two kind of blue lines. In an uninsulated building, that could simply be an area that's a little bit thinner than other areas, and in an insulated building it will mean an area where there's less insulation than other areas. So because those areas perform less well thermally, they allow the heat to transfer out of the buildings at those points, bridging or bypassing the more insulated areas. Because these are cold spots, because they are a colder temperature, the water vapour in the air is more likely to condense at these spots, so they get the condensation of moisture on them. And that starts to saturate the fabric at those points. And the more the fabric becomes saturated, the colder it becomes and the more attractive it is to condensation. So it creates a vicious cycle which just gets worse and worse in those particular areas. And one of the places that you'll commonly see that is in the window reveals, okay? So we might see that quite a lot in properties. You get this condensation, mould growth around the windows in the reveals, and that's because they are a thinner part of the dwelling. So when we think about how thick the actual wall is beside the window, when you go into the reveal, there's simply less distance to the outside, so they are colder spots. Other areas that you might find that are, for example, loft hatches, where the loft hatch is uninsulated, or where you've got kind of penetrations into the insulation at roof joists. So by understanding how moisture behaves and interacts with buildings, we can then understand how we manage moisture within the buildings. So thinking about effective heating, ventilation and insulation and how they impact damp and mould growth, they've got a key relationship in managing moisture within a dwelling. So we need heating to keep our internal air above that dew point and ensure that our surfaces are warm enough that they discourage condensation. And that of course links us to insulation. So we need to keep the heat within the dwelling to keep those surfaces warm and to tackle any cold spots. And we need a combination of heating and insulation. One won't work without the other. So if a house is poorly heated but has well insulated walls, the walls can still be below dew point. And if a house is well heated but it's poorly insulated, our walls can still be below dew point. So we need that combination of the two to tackle that temperature issue. And we also need ventilation. So we need to remove the humid air from the dwelling. That can be controlled, that can be uncontrolled in combination. So controlled ventilation being intentional regulation of the internal airflow, and uncontrolled ventilation being those kind of natural ventilation points. Although traditional houses are built with more natural background ventilation, they may have had impermeable surfaces added, and we may have sealed them up. We may have made them more airtight because we're looking for thermal comfort as well. So we might have draft-proofed our house. We might have, sealed up the chimney because we don't have a fire anymore. So we've removed a lot of the background ventilation, and we need to replace that. So what do we need from them then? So in terms of our heating needs to be efficient enough to heat the space, and we're looking for generally a temperature of 21 degrees C in living areas and 18 degrees C in our circulation spaces, and attaining that temperature is going to help keep our air above dew point. But it also needs to be affordable, so it's not beyond a tenant's means to heat the space, and understandable. So if the heating system isn't simple, and something like storage heating, if you've never come across that before as a tenant, it's really, really difficult to understand how that system operates and get your head around it because it doesn't operate like other heating systems. So if you don't explain the heating system to the tenant, they're not going to understand how to use it and be able to use it to its full potential. And in terms of making it cost effective, that links us directly to insulation. So a tenant can be pumping out the heating, but if we've not provided insulation, it's going straight out of our walls, our roof space. So 35% of our heat is going out through the walls, 25% through the roof. So what do we want? We want 270 millimetres of loft insulation and equivalent in other areas. So if we've got a flat roof, we need to insulate that. If we've got a rooming roof, we need to insulate that. For walls, consider internal wall insulation, external wall insulation. Although costly, they can give great benefits because that's where a lot of our heat loss comes from. And don't forget floors and draft proofing, which is another 15% of loss. Depending on floor structure, where you've got cold kind of concrete floors, that is insulating the floor is going to make a huge difference to the thermal comfort within that space. So thinking a little bit about EPCs then, what they tell us in terms of energy efficiency. So this is the standard tool for assessing energy performance in buildings, and it gives us a good indication of how a property is performing thermally. And the reason that links to damp and mould growth is that the better thermal comfort we have, the better we make our property perform thermally, the more we reduce damp and mould growth because we keep our internal air warmer and thereby we stop that condensation happening. So what we're looking at is being able to enable the tenants to keep the space as warm as possible. So when we look at increasing the EPC score, we're directly improving the occupant's thermal comfort, and that carries all those benefits with it in terms of improving their health. But when we make our buildings efficient to heat, we reduce fuel costs, and reducing fuel costs means that occupants can keep the building warmer. So it not only impacts their own thermal comfort and health, but it keeps homes warmer. We reduce the damage and deterioration to our building in terms of damp and mould growth by making them more thermally comfort. And we also have those wider societal benefits. If we keep our occupants happy and healthy, we reduce costs to the NHS. If we increase our EPC bands and our thermal efficiency, we reduce carbon emissions. And if we improve our ageing housing stock, then we reduce the need to build new houses and we protect our green spaces. So when we think about some of the legal requirements, it helps to demonstrate how meeting minimum energy efficiency standards doesn't just improve living standards, and it doesn't just improve thermal comfort, it can actually reduce damp and mould growth and help improve the property itself and protect it. So let's move on to talk a little bit about resolving damp and mould, and this is focusing a little bit more on kind of condensation and excess moisture issues, because solutions to traumatic damp, rising damp and leaks are a bit more obvious and situation specific. Generally, the important rule for any type of damp is to remediate not only the cause of the damp, but anything that's been affected by it. Because if we leave any saturated surfaces, they become colder and they attract condensation. So it causes that continual deterioration of parts of the building fabric. Whether we're a landlord or a regulator, if we think about responding to complaints, and we think back to what I said at the start of the talk about that impact on health, and particularly I'm thinking about the impact on mental health that damp and mould growth can have. So try and keep that in mind when you're dealing with a complaint. The state of mind of the person that you're dealing with, they could be depressed, they could be anxious, they could be really affected by what they're living with. So responding sensitively is our first real step to kind of dealing with the problem appropriately. and keep people informed of what you're doing. That really does actually stop people from feeling anxious and wondering what it is that's going on. Assess the urgency of the issue, and not just the urgency in terms of what you think and in terms of what the requirement of the building fabric is, but how urgent is it to the tenant? You know, how much attention did they want paying to it? Keep accurate records, so take photographs, make notes, make sure you've got a record of exactly what's happening. And sometimes with progressive damp issues, that can mean, you know, over a period of time, looking at how that issue deteriorates. Tackle the underlying cause, but carry out anything that's been affected as well. And if you have remedial works carried out, make sure you inspect after the remedial works and ensure that it's resolved the issue and that actually the works have been carried out exactly as you expected them to be. When you're inspecting a property, whether that's a routine inspection or responsive to a complaint, it's important to inspect the property both internally and externally. Try and match up what's happening on the inside and the outside in the same area. So, you know, think about the fact that if you've got a damp patch at ceiling level and you look outside and there's an issue with the guttering, that's suggestive that those two issues are linked. And remember that in the same room, there can be multiple causes of dampness and moisture. So you could have an issue with penetrating dampness in one corner of the room and condensation in another corner of the room. And these are the kind of things that you'd be checking for if you have signs of damp and visible mould growth within your property. If you're taking any damp readings, then the key features to look for would be whether readings occur towards the bottom of the wall or at the full height of the wall or just the top of the wall. And you're looking for any sharp drop-off between areas of high readings and areas of low readings. If you're doing any temperature readings, as well as measuring the air temperature, measure the surface temperature as well, because what you're trying to do is establish what that dew point temperature is and how likely it is that you're going to get water vapour condensing onto cold surfaces. Hygrometers can be a really useful tool as well to show how much moisture there is in a property and how hot, warm or cold a property is at a given time. And what you're looking for is a humidity level between 40 and 60% and a temperature between 18 and 21 degrees C. So thinking more about prevention after inspection, what we're looking at trying to do is keep the relative humidity down below 70%. And no surprises, what we're looking at, we're thinking about ventilating, insulating and heating. So we need to ventilate water vapour at its source. So it's not just about natural ventilation, it's not just about opening the windows and having air bricks. We need mechanical extract ventilation as a minimum in our high humidity rooms. And don't forget airflow, so even things like moving the furniture away from the walls is actually going to help us ensure that all our surfaces are kept warm. We need to insulate surfaces, so ideally lofts, walls, and ensure we avoid cold bridges and give that surface the best chance it has of not being a cold area where condensation is going to happen. And ensuring that we improve our heating so that we've got an efficient system that can attain 18 to 21 and that is affordable to do so. So it's a nice efficient system. And then there's a last measure of generating less water. And this is where we need to be really sensitive when we're thinking about this. It isn't about blame, it's about resolution and it's about being reasonable. So thinking back to what I said about the coroner's report in the Awabishek case, we don't want to be placing blame on people. We don't want to be saying, particularly to people who might already be depressed, who might already be anxious, we don't want to be saying to them, you're causing your own problems. You know, that's just going to aggravate the situation, make it even worse. We can talk to people reasonably, but we can't expect people to not bathe, to not wash their clothes and to not cook meals. Those are reasonable activities to undertake. You know, it is a house, it's not an ornament. We need to live in it. So we can talk to people about, for example, make sure that you've got the extractor fan running when you're bathing and make sure that the door's closed so our moisture-laden air isn't going throughout the house, it's staying in the bathroom and being extracted. But we can't say to people, take less showers. You know, it's all about what's a reasonable approach within that dwelling. So thinking a little bit about our thermal bridges, our cold spots and how we present them. So in terms of prevention, if you're fitting insulation, external wall insulation does have less opportunity for cold bridging than internal wall insulation. And that's because if you think back to that picture of the thermal envelope, it's easier to install a continuous layer that's consistent around the whole dwelling externally than it is internally, where you've got all those features like door frames to get around. It can carry less risk of further works needed due to the creation of cold bridges within that. If you're having insulation fitted, have a talk with your installer about what their consideration is of designing out the potential for cold bridges. You know, and a good retrofit installer and retrofit assessor will be able to talk to you about that. So one of the pictures on the screen there, you can see in the bottom left, that's actually some external wall insulation being fitted, wood fibreboard insulation. And you can see on the fittings there, there's a little kind of white circle in the middle of the fittings. That's a polystyrene plug. And the reason that's there is to prevent those screw heads from becoming cold bridges, because otherwise there would be a metal screw with a gap of air. So one of those measures to minimise the risk of cold bridges is making sure that we iron out all issues like that. So those little polystyrene plugs are one of those measures. And in terms of addressing existing cold spots, think about increasing insulation. So for example, if you're experiencing that type of issue in a window reveal, then you can just insulate all around the reveal, adding a layer of insulation to help mitigate that, to increase the surface temperature within that area. We've got numerous pieces of guidance around damp and mould growth. One of those is the British Standard for the Management of Moisture in Buildings. So that includes managing surface condensation, it includes managing relative humidity. And it's basically a whole building approach to moisture management, you know, describing sources of moisture and all different recommendations. One thing to mention with this edition, which is the 2021 edition, in terms of vapour permeability and what we said about how our more traditional buildings operate, this edition acknowledges that previous editions gave some incorrect advice on non-vapour permeable insulations. So previous editions recommended the installation of a vapour barrier on the warm side of the insulation, but this edition acknowledges that that can actually prevent movement of moisture, and in some buildings the best approach is to allow moisture to move through the structure and evaporate. And in terms of our building regulations, very similarly to what I said about the British Standard just there, when we look at parts F and L of the building regulations, there is also a different approach for traditional buildings in that ventilation and energy efficiency improvements should only be made to vapour permeable construction where it won't cause deterioration of the fabric of the dwelling. So really important to recognise though that doesn't mean don't do anything. What it means is that the measures should be appropriate to the dwelling, and it might mean that they don't meet the ideal prescribed standards, but we still need to make as much improvement as we can. In terms of compliance with legal requirements, there's a number of pieces of legislation to consider. I've mentioned minimum energy efficiency standards. Obviously, we're also trying to remove category 1 hazards. We've got damp and mould growth, we've got excess cold. So those are the legal requirements that kind of cover damp and mould growth. And I want to also draw your attention to the government guidance, which was published in September last year, and what that says in terms of the point that I've made regarding lifestyle. The guidance states that residents should not be blamed for the presence of mould in their homes, and that mould in homes should not be pinned on lifestyle choices, and that cooking a meal, having a shower and putting clothes out to dry are not discretionary activities. They're part and parcel of living in a home. So it's our responsibility as professionals, as landlords, to identify and address underlying causes that are causing moisture to condense on surfaces, and that can be structural issues such as heating and insulation or inadequate ventilation. On that note of guidance and regulation, it's worth mentioning the proposed changes to HHSRS following the HHSRS review that RHE carried out for the Department of Levelling Up, Housing and Communities. One of the changes that we were asked to implement was the introduction of baseline indicators, because the Housing Health and Safety Rating System is seen to be quite difficult to understand for non-trained persons, so for landlords to kind of get inside what's happening in an HHSRS practitioner's assessment. So the idea of the baseline indicators is that they help the system be understandable so that you know what a practitioner's looking for. So there are a set of indicative kind of ideal or expected standards to guide housing providers as to what standards we're expecting properties to meet. So they are more specific than the points I've got here, but they will introduce the concepts that a housing should have heating that's controllable and able to heat the entire dwelling at reasonable cost, and it should be sufficiently insulated to retain the heat that's generated. In terms of ventilation, the habitable rooms should have openable windows of adequate size, and bathrooms and kitchens must have mechanical extraction, which should be well maintained, in good repair and working order. And in terms of moisture and contaminant control, we're expecting properties to be watertight and weathertight, and rooms to be free from excess levels of observable damp and mould growth, and for their dwelling to have adequate space or facilities to dry clothes. And there's an example there in terms of that point about observable damp or mould growth. That's one of the baseline indicators that will be part of the new system. And you can see how that's relevant to damp and mould growth and excess cold. So you've got the baseline indicator on the left-hand column, and then some guidance around that in the right-hand column. And on this slide, I've just put some useful resources, some things I think it's useful if you're wanting to understand more about how moisture operates within dwellings. There's some useful resources there. And for anyone interested, we offer a full training session. So this presentation is just a small breakdown of the 3-hour training, and that's on understanding and managing damp and mould in dwellings. So it's a bit more comprehensive than what I've just delivered. Thank you for listening.